So we're starting our new unit. I believe this is the last quadratics unit. I don't believe, I know it's the last quadratics unit. And then after this unit, we're going to move on into other functions like absolute value, cubic, square root, things like that. Okay? Now, in this unit, we're going to focus not on quadratic equations, but quadratic inequalities. And the difference is in the equation, you have an equals. In the inequality, the equals goes away. And what does it get replaced with? Greater than, less than, greater than, equal to, less than, equal to. Okay? Now, I'm going to remind you that these are our two basic symbols, greater, less. And believe it or not, the biggest struggle I have with my kiddos is which one means greater, which one means less, and which one looks most like an L, the first one or the second one? The second one. That's the one that means less than. Okay? So, let's look at solving quadratic inequalities algebraically. You've learned several ways to solve quadratic equations. Okay? You have learned to factor, solve by factoring. You have learned to solve by graphing, square roots, completing the square, and formula. So you learned 5 ways. Today we're focusing on algebraically, which means out of the 5, we can't do graphing. We have to choose one of the other 4. Now, why do I keep teaching you the other 4 if graphing is the easiest? Well, does graphing always work? No. It doesn't work for what kinds of solutions? Imaginary. So that's why we have to keep learning the other 4. Okay? So the methods used to solve quadratic equations are also used as part of the process of solving quadratic inequalities. In plain English, that means that those same 5 methods that you learned for the equations are the same 5 methods that we're going to learn for use for the inequalities. So technically, you're not learning anything new. You're just applying it to inequalities. Okay? Now, when you're dealing with an inequality is going to result in one of 2 types of inequalities. It's either going to result in something called a conjunction. You're going to have a conjunction when you have a less than symbol once the quadratic is in standard form. Okay? And a conjunction, here's my silly way to remember, arises from a less than. Why did I write it that way? Because my symbol looks like a what? A C. Okay? When you have a conjunction, everything that's involved with that conjunction is going to be connected. So when you solve the inequality, if you write your solution as an inequality, notice that yes, I have 2 inequality symbols, but are they connected? Are they all together? Or are they separated? Look at the difference between these 2 and the other 2. Are these connected or separated? Connected. Okay? This is called an interval, the one in the middle. Do we have 1 connected interval or 2 separate intervals? 1 connected. And then the bottom one is called a graph. Check out your graph. Is your graph a connected segment or 2 disconnected rays? Connected segment. So everything results in something being connected. Conjunction, connected. See the relationship? Okay. Now, my silly way to remember the C, connected conjunction, I'm going to explain the Y in a second for those of you who like to know the Y. Some of you like to know the Y, some of you are just like, tell me how to do it. Okay? I like to know the Y. If you're like that, I'll show you why. The other type of inequality results from a greater than once it's in standard form. Okay? Greater thans result in disjunctions. Okay? I don't typically write my D's this way. I just wrote it that way because the symbol looks most like a D. And in a disjunction, everything is disconnected. So if you look at your answers as an inequality, okay, the first method, form rather, do you notice that it's two inequalities separated by the word or? Y'all see that? And in the other one, they were jumbled together. They were connected, okay? Look at your interval notation. Do you see how it's two intervals? That U in the middle means union. It's kind of like the word or. It's saying it's this piece and this piece, okay? And then look at your graph. Do you see how your graph is two separate rays versus the one connected segment? Y'all see that? So everything is disconnected. Again, I'll explain the why in a little bit. Make sense? Okay. Now notice, guys, in the set notation, look at your answers for the set notation and look at where you have brackets. When is it that we use brackets? What's the correlation? When it's what? Equal to. Y'all remember that? It's been a while since we've done set notation. But when it was equal to, we used brackets. Remember? Okay. All right. Now, first thing we're going to do before we start with example 1 is, since you're not one of my first classes, you're not, I've kind of refined the lesson by the time you get here, if you want to say that. But we're going to do away with example 2. Because what happened in my first couple of classes is everybody understood number 1, A and B. They were like, yep, easy, easy, easy. And then I threw in the words and they were like, oh, I don't know how to do it. But you do. Okay? It's just the words for some reason sometimes throw you for a loop. And so it's kind of early to throw in a word problem anyway, so I'm just going to do away with it for this lesson, okay? All right. So here we go. So letter A, we have x squared plus 9x is less than or equal to negative 20. Is that a quadratic? Yes. But guys, is it in standard form? No. So let's get it there. What has to move in order for it to be in standard form? The negative 20. And when we move it, it becomes positive. So what I have is x squared plus 9x plus 20 is less than or equal to 0. Now, is it in standard form? Okay. So now that it's in standard form, look at it and decide, okay, am I going to have a conjunction or a disjunction? Conjunction. Everything is going to be connected. Very good. Okay. Some of you just care that it's a conjunction. You're good to go. Some of you are wondering why. I'll explain the why. The next step is to find what's called your two critical points. And your two critical points are the points where the quadratic does, guess what? Intersects the x-axis, okay? Now, calculator, easy peasy, but I'm supposed to do algebraic today. Now, because I've been factoring twice as long as you've been alive, that's how old I am, I can look at this and know immediately that it factors, okay? You may not be able to do that just yet, but it's easy enough to try. It's easy enough to try with this one because it has a lead coefficient of 1. It doesn't have a number at the front. So you might as well try, okay? And if I factor it, I'm going to have two factors. They each start with x. And I need two numbers that add to 9, but multiply to 20. What combination of numbers does that? 4 and 5. So let me stop. Make sure you're good. You good? Okay. Now, when I find my critical points, what was the correlation between the factors and the solutions? They were what? Flipped, opposite. So if it's an x plus 4, what's the value for that one? -4. If it's x plus 5, what's the value for that one? -5. These are called my critical values. Critical points, critical values, either way. Guys good? Let me explain the why. For those of you who are wondering why is it a conjunction? Well, here's why. Okay? You don't have to write this down unless you want to. But here's the why. If I graph this quadratic function, it's going to cross the x-axis at my critical values, -4 and -5. Agreed? Okay. That x-axis cuts the parabola into what's above it and below it. What's above it is the two arrow parts, yes? What's below it is the scoop, the little u part. Agreed? Okay. Well, the symbol that results in a conjunction is the less than equal to. I have less than equal to. Which values are less than equal to 0? The ones above the x-axis or below the x-axis? Below. And what part of the parabola is below? Is it the arrows or the scoop? The scoop. Is that one piece or two separate pieces? One. And so that's why it results in a conjunction. So that's the why. Okay? Now, going back to the critical values, we can write our answer as an inequality, a compound inequality. You go from least to greatest. What's the lowest critical value? -5. And the highest? And you put x in the middle. These are always less thans. They will take an equal if the original symbol had an equal. Did the original symbol have an equal? Yes. So that's my answer as an inequality. As an interval, the lowest value in the interval is -5. What's the highest? -4. Parentheses or brackets? Why brackets? Equal to. Then you can write your solution as a graph. I don't need a fancy graph. I don't need all the little hashtags between the values. I don't even need for them to be proportional. I just need to know where the -4 and -5 go. And they should go to the left of 0. Agreed? Okay. You put circles above the critical values, -4, -5. Should I leave them open or should I fill them in, close them? Fill them in because of the equal to. And then do I connect to them or disconnect them? Connect, because it's a conjunction. Everything is connected. So these are the 3 different ways to write your solution. On a question, I'd probably only ask for one way. But do you have to know all three? Yes. Okay. With me there. All right. Let's look at letter B. So letter B, do I have a quadratic? Yes. Is it in standard form? Yes. All right. I did factoring on A. I guess I'll do formula on B because I have to use an algebraic method. Now, am I ready to identify my A, B, and C values? Okay, what's your A? What's your B? What's your C? Okay, so the quadratic formula is x equals opposite of B plus minus square root of B squared minus 4AC, all of it divided by 2 times A. And what is it that I encourage you to add? Parentheses around the B and the radical. So let's substitute in those values. What's the opposite of B? Negative 12 plus minus square root of B squared, which would be 12 squared, minus 4 times A. What's A? 2 times C, which is 13. All of it divided by 2 times A, which is 2. Now, let me backtrack a little bit. Right here, where it was in standard form, I should have decided, is it going to be a conjunction or a disjunction? Was it? Disjunction. So everything's going to be separated. Okay? All right. Back to the quadratic formula. Type all that junk that's in the radical, type it into your calculator, parentheses and all. Did you get 40? All right. So we have square root of 40. And rather than simplify the radical like we normally do, let's go ahead and take the square root, round it to the thousandth. How many places after the decimal is thousandth? 3. So second square root 40, and we get 6.32 what? 5. You round it up. So all of this goes away, and you replace it with 6.325. Now we're going to clean it up. X equals negative 12 plus minus 6.325, all of it over 2 times 2, which is 4. And then break it up into 2 problems. It's negative 12 plus 6.325, all of it over 4, or negative 12 minus 6.325, all of it over 4. With me there? Type it into your calculator. Remember, you have to do it in 2 steps. So, type in negative 12 plus 6.325, enter, divided by 4, enter. Round this one to the nearest tenth. How many places after the decimal is tenth? 1. So negative 1.4, is that what you guys got? Okay. And then do the same with the second one. Negative 12 minus 6.325, enter, divided by 4, enter. And what would you get? Negative 4.6. These 2 values are called my what values? Critical points, critical values. So now you're going to take your critical points and you're going to write your solution multiple ways. So one way is to write it as a graph. So number line, let's put 0 on it, negative 1.4, and negative 4.6. We're going to put circles above our critical points, critical values, and they are going to stay open because there's no equal to. And because it's a disjunction, your graph is disconnected. So they go in opposite directions. You can do interval notation. Remember that it's two separate intervals. You put a U in the middle for union. It's the union of those two intervals, okay? So the first piece, the one on the left, at the left, it's going to negative infinity, and on the right, it stops at negative 4.6. Okay, the infinities always take parentheses. The negative 4.6 is going to take parentheses because it's an unfilled circle. Then, let me write that a little better. I kind of jumbled it all in. Negative 4.6. Okay, and then there's my union. Then the second interval on the left, it starts at negative 1.4, and on the right, it's going towards positive infinity. The infinities always take parentheses. The negative 1.4 will take a parentheses because it is an unfilled circle, open circle. Then for the inequality, it would be two disconnected pieces. So for the first inequality, we're going to compare x to negative 4.6. And in the second inequality, we're going to compare x to negative 1.4. So from negative 4.6, your graph is going to the left. And as it goes to the left, those values are getting less than. So you need a less than. And on the right, from the negative 1.4, those values head to the right, so they are getting greater than. And so this is all of my solutions. Like it's the same solution written in all three forms. And that's all there is to solving quadratic inequalities algebraically.